Greetings for everyone, especially for our reviewers. So, in this session, in this video, we're going to explore research methodology in computer science. And the topic that we're conducted in the study is the comparative study between a machine learning that is optimized with genetic algorithm and deep learning implementation. So, the both models will be used in an intrusion detection system, which is used for detecting network threats. The part has been already been divided from the abstract until the conclusion. For the very first part, we're going to explain abstract that will be explained by my friend here, Dandy. Before we even start, let us introduce ourselves. My name is Filbert, and here we got also Dandy Antarixa. So for the abstract and the literature review will be explained by my friend here, and then the rest will be by me. For Dandy, please May.
Okay, the abstract for this research paper is to compare the effectiveness of intrusion detection system or IDS based on clustering optimized with genetic algorithm and deep learning models using neural networks. The focus of this research is on analyzing the recall metrics to achieve higher threat detection accuracy. Okay, the next one is the literature review. Intrusion detection system or IDS are essential for ensuring the security of network infrastructure, especially in the face of evolving cyber threats. Recent research has explored various approaches to optimize IDS performance, including traditional machine learning models and deep learning techniques. The traditional machine learning models, such as random forest, support vector machine, and the nearest neighbors to detect anomalies. The genetic algorithm or GA are commonly employed to optimize these models by enhancing feature selection, improving classification accuracy, and reducing computational overhead. Studies have shown that combining studies have shown that combine GA with models like random forest and can effectively identify patterns in network traffic. Okay, the next one.
Okay, so continuing to the dataset that we are using for this study. So the dataset that we are using is KDD 19099 that is worldwide known or worldwide used for intrusion detection system models. So the characteristics here is quite easy actually. It includes all the network traffic data that is not actually ready labeled, so it's still being raw. So here the data itself needs to be pre-processed before we even use the data set for training both models. So the validation method here that we are using for training the both models is that the data set that we're using, the KDD1 1999, the 80% of the data set will be used for training, and the 20% or the rest will be used for testing. So continuing to the method section, we are actually using ensemble-based machine learning model in here. So the specific algorithm that we are using here is that random forest algorithm that is optimized with the genetic algorithm itself. And for the deep learning model itself, we are using neural networks that is, of course, with several or a lot of hidden layers in that is should resembles the deep learning model. And for the evaluation metric itself, we are focusing on the recall metric to assess threat detection capabilities, and we're compared both of the performance of the model itself by different attack scenarios. So the different attack scenarios in here is that we are going to see the performance of each model in the normal traffic section and the attack traffic sections here. Which is first we are going to discuss about the result of the genetic algorithm with random forest algorithm. So we can see here that the class or the normal traffic itself, the first scenario in here, we can see that the precision, the recall, the F1 score, we can say all the parameters in here is at 1. the reason why we got the value in here, the reason of why it can be 1 or 100% of the value itself, is because it's not technically 1, but it got rounded up by the system. So the reason why itself, it's because it got rounded up. The actual result, it shouldn't be at 1, but because the score is near to 100% itself, that is the reason why it got 100% as it values. And then we can see for the attack traffic itself, for all the parameters, it's also got the same value, which is 100% or 1. And the overall metric itself, as you can see here, the actual result that is shown in the model, it should be 0.19996, and with a lot of numbers in the rest, but it got rounded up because we only taking 2 numbers behind. And that is why the reason we got 100% for the overall accuracy. And we can see here also for the macro average, all the parameters in there is also got 100%, and also the weighted average, it got 100%. Since a sample method will increase the model's performance, it it won't be rare to see that the genetic algorithm will work best with random forest algorithm. So that we can see here with the comparative study of neural network algorithm itself, we can see that the normal traffic in here, it got a precision of 0.98. The recall is 0.99, and the F1 score is 0.98. But when we see here the attack traffic itself, the precision and the recall got slightly different in here. It got like vice versa in here. So the precision here, it got slightly higher than the recall compared to when we see it from the normal traffic here. But the F1 score still remains the same. It's in 0.98. So the overall metrics that we can see, or from the result that we're already made before, the accuracy for the neural network algorithm itself, it got 98%. The macro average for all the parameters in there, it got like 0.98. The weighted average itself, it got 0.98. So what we can conclude here is that the result of the study indicate that the use of a genetic algorithm as an optimization method can provide competitive performance in the development of intrusion detection system. Meanwhile, the neural networks offer strong capabilities in handling complex patterns but come with higher computational costs. The choice of the appropriate method should consider the balance between performance and efficiency in the context of IDS applications. Because when we're choosing between these models, or whatever algorithm that you want to use, it should be with or come with thoughtfulness, because it matters from which scenario will you solve, because it's all about the use cases in here. That's all that we can explain. Thank you. Sorry for if there's any mistake in our words. Thank you.